Hello everyone, my name is Vivek Srivastava and I am from ABES Engineering College, Ghaziabad. Today, in the lecture of Database Management System, I will cover the topic Entity Relationship Model. But before going in the deep discussion, we should know about the database schema. So database schema basically divided into three parts: conceptual schema, logical schema, physical schema, external level schema or view level schema, which is also called sub-schema. Schema basically represent the method by which we can represent the database. ER modeling. In ER modeling, I will discuss about entities, relationship, and attributes. So, first of all, what is database schema? Software applications are created to manage data and to help transformation data into information, by which we can transfer the data in the form of information, which is very essential in the field of DBMS. A database design is an essential component of any application development. Database design is essential because without database, we cannot know about the applications, what we are going through, and a lot of things are dependent on database design. Database designing is a necessary step in the process of creating any complex software. Now, this is the overall design of the database of an organization, and which is also called a schema. In this example, as you can see that there is a vehicle schema where the detail about the vehicle is represented in the form of schema. We can visualize it, how database should be built, like model have model ID, model name, first production years. These are the attributes. In vehicle, we have vehicle ID, and vehicle model year, a lot of things. So this is in this given example, a schema has been represented in a diagram for vehicle sales. Now, next thing is data abstraction. Data abstraction refers to the process of hiding irrelevant details. For example, like when we send mail through Gmail, we need not to know about the details of server located. This detail is irrelevant for the mail sender because we are only interested in the data in the mail. Data abstraction is divided into three levels to achieve data independence. Data independence means user and data should not directly interact with each other. So there are three levels of data abstractions, which are view level, conceptual level, and physical level. So in the given diagram, you can see the schema at different levels. The schema defined at various levels of data abstractions are conceptual schema, logical schema, physical schema, and external level schema oblique view level schema, which is also called sub schema. Now, what is conceptual schema? The conceptual schema design provides high-level data model, a conceptual framework to specify the data requirement of the database users and how the database will be structured to fulfill these requirements. And conceptual schema or conceptual data model, the schema developed at conceptual design phase provides a detailed overview of the enterprise. It describes the following things. Number one, the things of significance to an organization, like entity types, its characteristics, like attribute of the entities, the association between pairs of those things of significance, like relationship, which is also called ER model, that is entity relationship model, which I will discuss later in this PPT. Now, logical scheme. It is a database design at conceptual level of the data abstraction. In logical schema design, we have the conceptual schema is transformed from the high-level data model into the implementation data model. It defines how the database should be implemented using a specific DBMS. The schema defines all the logical constraints that need to be applied to the data stored in the database. These are the steps. Number one, we will select the data model, like which data model we are going to use, like relational, object, network, hierarchical, etc. Transform conceptual model into selected data model, like ER model to relation. And third, implement all constraint as per selected data model. This is the overall work of logical schema. Now, let's discuss about physical schema. Physical schema is the database design at the physical level of data abstraction. It describes how the data is organized in files, internal storage, structures, and access paths. The logical schema is mapped to the physical schema using DBMS tools selected as per selection of data models in logical schema phase. For example, RDBMS tools like Microsoft SQL Server, Oracle, or IBM's DB2 are the powerful tools by which we can perform the given task. Now, view schema or external schema. View schema or external schema defines the design of the database at the view level of the data abstraction. It defines how an end user will interact with the database. It shows only those data to a view group in which they are interested and hides the remaining details. Example, for a card seller, only selling details are available at the view level. For HR, only employee information is available at the view level. So these are the examples by which we can understand the view schema or external schema. Now, data modeling process. The process of data modeling is represented in the given diagram. As you can see that requirement collection and analysis, then conceptual design, then logical design, and finally we will get the physical design, which is also known as internal model. So this is the data modeling process by which we can convert the specific, we can solve a specific problem. Now, modeling. This is a very important concept in DBMS, modeling. So because modeling is important, so we must be very, careful while choosing the entities and giving the attribute names and giving the primary keys. So I will discuss and I will explain each and everything in detail. So let's start with the entity relationship modeling. So entity relationship data model is based on a perception of a real world that consists of a collection of basic objects called entities and relationship among these objects. Entities are described by a set of attributes. I will later discuss what is entity and what is attribute in detail. So the entity relationship model describes data as entities, attributes, and relationships. The database design created using these graphical symbols is referred to as entity relationship diagram or ER diagram or simply ERD. This is the example of ER diagram showing entity, attribute, and relationship. The rectangular boxes are shown in this diagram is known as entity. The oval shape attributes are called attributes, and like for if we consider doctor here, like if we consider doctor, then one second. Doctor have three attributes. Number one, ID. Number two, first name. Number three, last name. Similarly, patient have four IDs. Four attributes. Number one, ID. First name, last name, insurance number. Diagnose have two attributes and specialization of doctor has two attributes. Doctor and patient is connected through a relationship has. So this diagram shows entity, attribute, and relationship between the entities. An entity is a real world object which can be a person, place, or thing that can be uniquely identified and distinguished from other objects. Example, student, department, country, car, course, etc. are the example of entities. Entities are of two types. Number one, tangible, and number two, intangible. Tangible that exist in real world physically, like student, car, etc. are the tangible entities. And intangible attribute that exist only logically and have no physical existence, like course, department, etc. It does not have any physical existence, but it logically exists. In ER diagram, entities represented through rectangular box, entity type. Now, entity type defines a set of entities having a common set of attributes. Each entity type is defined by its name and attributes. Example, all the students in a college or university will have the same set of attributes. The student becomes entity type. Entity set. The collection of entities of a particular entity type in the database is called an entity set at any point in time. It is also called the extension of the entity type. For example, entity type student, entity set. A single occurrence of entity is called entity instance. As you can see in the table, a single occurrence of entity, like if you consider Satyendra Kumar Bhatia's data, then a single row is called entity instance. It will show the instance at which the particular data is recorded or retrieved. Now, attributes. Every attribute has a set of properties that describes the entity. For example, a student can have attributes like roll number, first name, middle name, last name, date of birth, gender, etc. Attributes are represented in oval shape attached to the entity. In the given diagram, you can see that a student is considered here as an entity, and student ID, email ID, age are considered as attribute of the entity student. Now, types of attribute. The attribute of entity can be different types. We have a lot of categories of attributes: general attribute or attribute, key attribute, multi-valued attribute, composite attribute, and derived attribute. Now, what is key attribute? The attribute which helps in the unique identification of entities are called key attribute. Suppose we have a lot of attributes for the student. As you can see in the diagram, student have roll number, first name, middle name, last name, DOB, and gender. But here the roll number can uniquely identify the student among a list of the students, because roll number is unique for every student. So such attribute have unique values like roll number of a student, course ID of a course, and department ID of a department are the key attributes. While representing such attributes, we need to underline them. As you can see in the diagram, roll number is underlined because this is the key attribute. Multi-valued attribute. The attribute which can have multiple values for an entity type is called multi-valued attribute. Suppose in the given example, student can have multiple phone numbers using attribute phone number, or a student can have multiple hobbies. So these are the multi-valued attributes. It is represented as double line oval, because you can see in the diagram, student have hobby and phone number as a attribute, and it is considered as a multi-valued attribute because student can have multiple hobbies, student can have multiple phone numbers. So it is represented in double line oval. Derived attribute. Third is derived attribute. An attribute whose value is calculated from another attribute is called a derived attribute. Suppose you know the date of birth of any student, then we can derive the age of the student by calculating the current date by date of birth. So age attribute can also be derived from another attribute, DOB. So these kind of attributes are represented as dotted line oval shape to represent a derived attribute. So in the given diagram, you can see student have a attribute age, and which is dotted line oval shape because age is derived with the help of date of birth of a student. Suppose, and if we consider another example, suppose you know the salary of any employee, then you can derive the tax calculated by the formula. So the tax calculation will be derived from the annual income and the saving, whatever the things are given. Now, entity types. We have two types of entities: weak entity and normally, and the second is strong entity. So first one is very important: strong entity and weak entity. The entities those don't have a primary key is called weak entity, and the entities those have a primary key is called a strong entity. So here is the example of a strong entity. Strong entity type are those entity types that have a key attribute. A rectangle in the ER diagram represent a strong entity type. Here student is the strong entity which is represented through a rectangle. Now, weak entity type. An entity type may not have a key attribute to uniquely identify each entity instance. Such an entity is termed as weak entity type. Suppose if we consider an example, section. A section does not have its own key attribute, so section is a weak entity set. Weak entity must be associated with another entity type called the identifying or owner entity type. Example: Department is the owner identifying entity type of section. A weak entity type has a partial key, which is the attribute that can uniquely identify weak entities that are related to the same owner entity. Example, section name is the partial key of the section weak entity, as a section name uniquely identifies one single section for that department. As you can see in the diagram, a double outlined rectangle represents a weak entity type. The partial key is represented as dotted underline. So here section is the weak entity and section name is the partial key. So section and section name are shown in the diagram. You can easily understand. Relationship. When two or more entities are linked together to manage the related information, such linkage is called relationship. Every student belongs to a department. These two entities have a relationship. Use a diamond symbol to create the relationship between the entity types. In the given diagram, you can easily see that student and department is connected with the help of belongs to. There is a relation and it is shown in a diamond shape. So it is a relation and name of the relation is belongs to. The student belongs to department. So this is the representation of relationship. Relationship type. When two or more entities are linked together to manage the related information, then such linkage is called the relationship type. For example, every student belongs to a department. These two entities have relationship types belong to. Use diamond symbol to create the relationship type between the entity types as in the given in the diagram. You can easily see that. Relationship instance and a set relationship set. Relationship instance is an instance that associate an entity instance from an entity type to another entity instance to another entity type to establish a relationship among various participating entity types. A relationship set is the set of all relationship instances that participates in any relational relationship type to define a relationship between participating entity types. So in the given diagram, you can see the relationship set and relationship instance. Both the things are given in the diagram. Relationship degree. The degree of relationship type is the number of participating entity type. Hence, the belongs to relationship is of degree 2 has only two participating entity type, that is student and department. A relationship of degree 2 is called binary because there are two terms. A relationship type with a degree 3 is called ternary relationship. So in the given diagram shows a ternary relationship because department, faculty and course, these entities are connected with the help of course allocation relationship. So this is called ternary relationship. Role names and recursive relationship. The role name signifies the role that a participating entity from the entity type plays in each relationship instance and helps to explain what the relationship means. For example, in the belongs to relationship type, student plays the role of a student, department plays the role of an academic department. The role name becomes essential when the same entity type participates more than once in the relationship type in the different roles. Such relationship types are called recursive relationships. Example of role names and recursive relationship. The works for relationship type is a recursive relationship type. It relates HOD and faculty entity type. You can see in the diagram. HOD and faculty entities are members of the same faculty entity set. The faculty entity type participate twice in works for, once in the role for a faculty and another in the role of a HOD. Attribute attached to a relationship type. A relationship type can also have attributes attached with it, which are called descriptive attributes. So department, faculty, and course are joined together with the help of course allocation relationship, and course allocation relationship have two attribute: academic year and semester. So this is the example of attribute attached to a relationship type. Now, these type of questions can be asked during the examination. These are some important questions. What is entity relationship model? What are the main components of an ER model? How does the ER model differ from other data models? What are the advantages of using the ER model in database design? How are the relationships represented in the ER model? So you can practice these type of questions. These are the references. If you want to further study in deep, then you can go through these books, Koth and Nawate, which are very popular in DBMS. So thanks for watching this video, and in next video I will cover the further syllabus of the subject DBMS. Thank you for watching this video.